this throughout the day today and through Flex yesterday. When you're setting up the gift basket problem, is you guys are forgetting what it's asking you to maximize. They're asking you to maximize the number of books, not costs.
Wait, I have a stupid question because that was stupid. Isn't the answer actually 7? Because that's the most amount of books that you can put in there, 7, right?
I don't know.
Well, it says
You-
or.
Yeah, or, not and. So the most is 7.
Yeah.
What?
So Autumn, like.
The most you can have in there is 7 paperbacks.
I got
There
8.
it tells you 3 or.
Yeah. But it probably is 7.
Wait, was it
can't
at 8?
have
Could
So
you
the
add
problem
1 to
is for us.
7?
Yeah, I got you.
I didn't use 7, I got 8. But then
I got 107 paperbacks.
It's wrong.
I think it meant like you can have a maximum of 7 paperbacks, but you can have more.
I switched around, so I had 700.
Yeah, because then if you have 7.
No, I never thought of it that way. I see what you're saying.
That's how I read it. I was like 7.
Is it just an odd question? Yeah, I got like a decimal answer and I was really
I never would have thought of it that way.
Grammar is
The
still
way
important,
yeah, grammar is weird.
So
but it's still important in math.
Well, the way I mean, I just read it as you can't have any more. It won't hold more than 3 books, 3 hardcovers, and it won't hold more than 7, like in combination. Is what I was thinking of it as.
Yeah, I mean.
But I see what you're saying.
It was.
Maybe it should be like and or.
I know what
It
it should be 2 separate problems.
And so or. That's the most amount of books you can have in there is 2.
but yeah.
I see what you're saying. It should be a mixture of at most 3
Yeah.
mixed with at most
But
7.
you wouldn't even be able
So
to
let's think of it in terms of it mixed with 3 and mixed with
And
7.
you wouldn't
How's
even be able to
that?
use them off just the cost. One, no, but then we'd be like 10.
But I never would. I honestly, in the amount of times that I've done this problem, no one's ever thought that. Or if they have, no one's ever said it. So think about what they're asking you to do.
The most I can have is 7.
The maximum number of books. How do you count books?
add that.
By ones. So you have the maximum, we're going to call this our objective function, I'm going to use C, is the number of hardcover books plus the number of paperback books. The 24 and the 8, 24 and the 8 relates to the cost, not the multiplier of books. So a lot of people were putting this as 24 plus 8 because they were thinking that you have to maximize your costs. I'm maximizing the dollar amount here because your dollar amount is bound by only being able to spend $80. So it says that you can spend $24 on a hardcover book plus $8 on a paperback book, and it has to be less than or equal to $80 overall. That's where that one comes into play. I saw a lot of students using the 24 and the H with both the amount of money you have as well as the constraint, the objective. Okay. And then the other part was you can't have more than 3, and you can't have more than 7. Obviously, you're not going to have negatives, correct?
Yeah.
So when you go to plot this one through, the first thing I would plot are my intercepts of the 24 and the 8 to get a scale. We'll call this H and P. My P-intercept is easy, it's 10. The H-intercept is 3.3. Is it 3.3? No. 10, yeah. Okay. Connect. Moving inward. My H has to be less than or equal to 3. Going that way. My paperback has to go this way at 7. It's less than here. So what you're doing is you're figuring out the points on the line through there. So your ordered pair is going to be at 0, 0. Mom's not going to like that. 3 and 0. 0 and 7. Now here, these are going to be relatively simple to find. Because you know your number of hardcovers and you know the number of paperbacks. So if I use 372, so paperback would be 1. Okay.
Wait,
This is the part that's confused about. I got these.
What we're doing here is we're just substituting it. Okay, we're substituting it. By doing that, this is your value of h.
Yeah, I guess.
So I just substitute h into here. Solve p.
Oh, then you put it in.
Yeah, that's all it is. It's just like the x and y stuff, being vertical and horizontal. And it comes from being, make sure you label your axes to know which one goes where.
Okay.
When I say the other one, if you put 7 in here, you get 56. Subtract over h is going to be 1. Now it's asking you for the maximum total number of books. Of those ordered pairs, what gives you the most books? 8, which would be 1 hardcover and 7 paperback.
But you can't fit that.
We've already discussed this. You were dancing. It's written grammatically bad, and I never noticed that before.
So you don't.
Nobody ever noticed.
So
No, nobody cares. Speaking of nobody caring. Hi! Missed you.
What is that?
Thanks.
These two related?
I don't think so.
Technically, I'm concerned that
Seven.
the way it's written, it's more of a logic question because they wrote it wrong.
Very correct. Oh, that's the other one. Sewing dowel clothes. This sounds like a very fun thing to do.
Who buys those?
Who doesn't buy those?
Alright. So I guess there's money in dowel clothes.
Have you ever seen the American Girl store? Oh my gosh. Look at the outside of it.
It's done in here. Alright, so you're going to sell party dresses and casual sets. Party dresses, because they're fancy, take longer than casuals. You make a profit of $9 on party dresses and $4 on casuals. If you have no more than 30 hours to sew and you can make it most 15 outfits to sell, how many of each kind should you sew to maximize profit? So what are you trying to maximize?
Profit!
Profit. So this right off the bat, you know your profit is what you're looking for. You make $9 on a party dress and $4 on your casual. I'll use P and C. After that, sorry, what's that? After that, you just have the other part they're talking about was time. In this case, they're talking about the time that you have available is 30 hours. Well, how many hours does it take to make a casual set? 1 casual plus 2.5 party is less than or equal to 30. You can make at most 15 outfits. What does that one look like?
15 is
P is less than or equal to.
Because you're combining the both casual and the party.
Well, I did that one.
All right. The last bit then is, are you going to make negative values? Of course not. This is a this is a first quadrant problem. Okay.
That's the one great thing about being in school. I can use some of them.
So when you set this through, ladies and gentlemen, it's enough. Okay. When you set this through, what's going to be your worst or the largest of your intercepts?
30.
The 30. I'm going to put that one in first. We'll call this one the C. Repeat. So I'll put 30 here. What's the other one then?
12.
12. Okay.
So I wrote the equation differently and I didn't combine them, and I wrote P is less than or equal to 12 and C is less than or equal to 30. Is that okay?
No, because if you're doing that, then it means it's horizontal or vertical. Here, there's a
Diagonal.
diagonal here. Okay. So these two guys combine through. Now your intercepts are at 15 and 15. So there's an intersection here. These are both moving inward. You need to figure out where those two run into each other. Well, in this case, it's probably the easiest to do a linear combination, just subtract the two equations. By doing that, you're eliminating the C. Everybody see that? Just doing that, it just works out a little bit quicker. You get 1.5p is 15. So p is, what, 10?
Yeah.
So if p is 10, what is c?
5.
5. So this ordered pair here is at 5 and 10. Now it's just a matter of substituting into your profits, see which one will work. Is it at 0 and 12, 5 and 10, 30 and 0, or doing nothing at all? Oh, thank you, yes. I didn't put my label here. Okay. And if I'm not mistaken, I think you wind up doing rather well if you make 5 of one and 10 of the other.
Yeah.
So it wasn't that as scary as it sounds, right? All right.
I'm sorry, I have
Casual
another
and 10 party?
Yeah.
Why does it say, it goes from C plus P is less than or equal to 15 to 1.5P?
What I did here, Ben, is I had to solve where these two guys intersected, and I did it via what's called elimination. I subtracted, since the C values were the same. I could have used substitution, gotten it by itself. I noticed that right away, the way they were stacked. Just subtracting that just was a quicker way of doing that. That's all. Got it. Okay. Yeah, you can do it multiple ways.
Then it doesn't matter which way you do it.
It
It doesn't matter which way you do it.
She was rocking the mic. She's like, "How did you know that?" Now you're a farmer.
Is this the problem you're talking about?
Oh, I hate it.
Yeah. So, well, it doesn't take into consideration the fact that, soils change and where you're at. It's just like you guys going off on tangents, like Leaf was trying to make the day go by a little bit slower. This problem is a lot, I kind of wish that I had time to, retype it to make it a little bit cleaner. If you went through all of it, it wasn't that bad. You just had to kind of piecemeal bits out of each of the paragraphs. So you have two crops, corn and soybeans. Expenses are $6 for an acre of corn, 12 for an acre of soybeans. Each acre of corn requires 12 bushels of storage. The other one is 16. You have at most 3,600 bushels of storage and $2,400 to spend. Choose variables, blah, 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 blah. Graph the solution, blah, 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 blah. Suppose the farmer earns a profit of $24 for each acre of corn and $48 for the beans. Find two ways that the farmer can satisfy the conditions while maximizing the profits. So you know you have to maximize profit. So your profit is going to be 24 for corn plus 48 for beans. We okay with that?
Yeah.
The other two bits that you have are cost and storage. We okay with that? Yeah. So cost-wise, you know that corn is $12, and how much are beans?
16.
Was it 16? Yeah. Or
6.
oh, I'm sorry, 6. I was reading. I saw corn for 12. I'm sorry. So it's 6 for corn and 12 for beans. And how much money do you have to spend?
25.
Okay. Then storage goes 12 and 16 respectively. And you had up to 3,600 in storage. I do believe this question said write 4 inequalities. That's 2 of them. What are the other 2? Zeros. In this case, it's because you can't have negative amounts. And it's kind of implied into that. That's why they say they're asking for 4. I've had people go, I can't figure it out. Well, people did that already, and they already have plotted it as a first quadrant problem. So,
I don't know how you still got those.
okay. So when you go to plot this one through, I'll get it tomorrow. No. That's when I go to plot this one out, what I've suggested to do is get a GCF. Make this look little bit easier to work with. Do you have to?
No.
It's just a little bit easier to do. Everybody see what I'm talking about? If I take a GCF, it just becomes a little bit cleaner.
Yeah.
I mean, you still get the same answer, so it doesn't really matter. Of all these guys here, you wind up with, let's see, we have intercepts. We do beans, corn. My bean intercept is at what, 200?
Yeah.
Corn intercept at 400?
300.
400. Okay.
400 divided by 6.
Oh, yeah, 400.
So 200 and 400. And we're moving inward. This one's at, what, 300? Oops.
300 and
300 and
220.
now, if you use the method of just like simplifying out one of them, it's just a little bit quicker to find the intersection point, but it's really not that bad. Here, if you get C by itself and divide everything out, you get C plus 2B was 400. So C is 400 minus 2B. Substitute through. What is that? 4,800? Eight. And what do you get for B then? 150?
Yeah.
Oh, I didn't do the I just write.
And then your C would be
100.
100.
I just replied to it.
Then it's just a matter. Then it's just a matter of substituting in. And where did you get for your maximums? 150 and 100. Was there a second one?
Yeah,
0 and 200. And that's possible. It's completely plausible. And that's where the whole idea with leaf going, well, you want to plant the other ones so that way you get crops to change and turn around and markets change and you want to be ready. Yeah. So there, yeah.
How do you do on that test?
On this one? It's fine.
I just didn't know if you made it harder than
No.
what. Behind.
I had some. I got a couple really. Like I say, it's tough to come up with really good ones. At least, so I try to save a few of them, and you can mess with numbers and mess with things around. And I've got a couple really good ones that I'll give you guys later.
Oh, yeah.
But they ain't practice, right?
No.
I kind of like them.
Oh, can you?
As long as they're not like that.
It'll be worded fine. Let's do this then. Have we done all these?
We did one and four.
Yeah. Yeah. Plus, we'll quiz this tomorrow. I might give you two of them. I'll give you a couple for tonight, and we'll call it a day on this. That way we can start something fresh coming Monday.
Okay, good.
I think we do two of these in a half an hour, right?
Yeah.
Yeah. So do this for tonight. In section 3-4, I've got some word problems. It's numbers.
Mr. Murray, can we keep this in study?
Yeah. It's 166 again.
No.
Someone listen. Not gonna lie, 23 is tough, because there's a fraction involved. Oh my gosh. Use a decimal in your calculator.
Oh yeah, there's a fraction one on the, whatever sheet this is.
166, remember?
The last one.
Oh, wait.
I know, well, it was, it's 21.
So
8, 21.
if you don't. So I guess you just go with amount of crop.
Isn't there? Wow.
Wow, you have a heart of a bar. Congratulations.
Yeah. 1 second here.
And then the positive referral.
I got a positive.
You not here tomorrow? We'll do it Monday then. That's what
That's the whole problem.
That's badly written.
I didn't write down the